Okay everyone, this is the fifth video in the series on vectors. We're going to focus in on what is a position vector and how we're going to use them. Okay, so here's an example of a position vector. This one's called OP. It tells you the position of point P with respect to the origin. It tells you the distance and direction, so magnitude and direction, point P is from the origin. So we can designate it as OP, like the vector from the origin to P, or as small letter p. Position vector A is the vector from origin to point A, so it's OA. Position vector B is the vector from the origin to point B, OB. Every position vector will be called OA, OB, OC, OD, OE, OW, OX, whatever. And we'll start with O because it's coming from the origin. Okay, here's a plane, and we've got 4 points there. We've got the origin, and then P, Q, and M. Position vector OP, we can designate it small p. OQ is called Q. OM is called small m. Okay, all the position vectors start with O because they're coming from the origin. Now, point P is 6, 5, so the position vector is 6, 5. Or you could write that 6i plus 5j. Okay, coordinates are written in coordinate form. Position vectors are written as column vectors or in component form, 6i plus 5j. So same with Q. Q is 4, negative 4. So position vector OQ, or Q, is 4, negative 4. Same with OM, negative 3, 6. Is the coordinates here. The position vector is negative 3i plus 6j. Here's a really helpful use of position vectors. If we want vector PQ, well, as we've seen before with our vector geometry, that's PO plus OQ. To get from P to Q, you can go straight there, or you can go via O, so PO plus OQ. Now, OP is P, so PO is negative OP, so we've got negative P there. OQ is Q, so there we go. So PQ is Q minus P. That's pretty easy to remember, and that will be really helpful solving a lot of problems. Another example, showing that it doesn't only work in the first quadrant, it works anywhere. QR, that's QO plus OR, and QO is negative Q. So negative Q plus R or R minus Q. So QR is R minus Q. Remembering this little trick is going to help you solve a lot of problems. Okay, here's another example where this is useful with finding distance and finding midpoints. And we'll look at this example, and hopefully this will help you understand a bit more. We have point A and point B. We're in 3 dimensions here. So point A is negative 1, 2, 3. So the position vector of A is negative 1, 2, 3. Point B is 0, negative 1, 1. So position vector is 0, negative 1, 1. Vector OA goes from O to A, but the distance is the magnitude of that vector. So these two, this vector is root 14 long, OA, and OB is root 2 long. Now I want to find the distance from A to B, and there's actually 2 methods for doing this. Okay, the first method is by using a formula you'll find in your formula book or that you've known for a while, distance between 2 points. The other method, or the newer method, is that we find out what AB is, when that's B minus A, and then we get the magnitude of it. I think that's probably easier. There's no difference, and it's the same numbers, but that might be a good way of thinking about things sometimes. Now, to find the midpoint, you'll find a formula in your formula book or in your textbook that the midpoint is just, it's like the average of the 2 points. So you look at the x values, and halfway in between -1 and 0 is -0.5. Halfway in between 2 and -1 is 0.5. Halfway in between 3 and 1 is 2. There is a second method you can use using position vectors, or vector geometry actually, saying the midpoint M, well, you can find its position vector OM by going OA plus half of AB, and you'll get the same answer. You can do that yourself and check it and see if it works. Alright, good luck with that. Stay tuned for my next video.